It's finally occurred to me that these phase shifts that Rosemary is talking about must be the phase shifts within the oscillations themselves. She might be talking about the difference in phase between the voltage drop across the current viewing resistor and the battery voltage or shunt voltage oscillations. Okay? Well, it's very easy to explain that that's what you're talking about if that's what you're talking about. Okay? The only place that I can find any place that this is actually shown in Rosemary's data is in paper 2 figure 8, where she shows the expanded oscillations, and you can indeed see that the current viewing resistor and the battery voltage are out of phase, as they should be, or if the phases shifted, as she puts it. Okay, well, here we have a little bit different setup. I've got one channel of the oscilloscope looking across the current viewing resistor. That's the top channel, so that's the CVR trace, and it's being shown at, oh, I'm sorry, the CVR trace is the bottom trace here. This is the current viewing resistor trace, and this is the common Mosfet drains up here. The current viewing resistor trace is being shown at half a volt per division. Okay, and I've tried to set its baseline somewhere. Excuse me just a moment. So the baseline I want to set right there. This corresponds to the offset setting of digital oscilloscope. You're just setting the position on the screen where the trace will appear and where its baseline is. That's all that the offset setting does. Okay, so there's where my zero marker is going to be. Turn it on, you'll see that the main portion of the trace is just exactly at the zero line. The only time that there is current flowing in the current viewing resistor is during this portion here, which of course is when the 555 timer is sending its negative pulse to the Q2 transistor stack. Okay, so here's the oscillations on the current viewing resistor. Here's the oscillations on the Mosfet Common Drains. Okay, the scope is still warming up, so it's jittering a little bit. So I'm going to go ahead. What I'm going to do now is go ahead and increase the time base setting until we can actually display that. Now, at the higher time base settings, the scope's a lot better at maintaining phase relationships, true phase relationships. So there we have now the expanded oscillations. We're looking at a time base of half a microsecond per division, right? And if we, well, you can count and divide. Everybody who's watching this, I think, can count divisions and peaks, and then divide the number of peaks by the number of divisions times the time base to get the frequency of this. And for my system here, it's running about 2.4 megahertz, something like that. I haven't actually measured it on this particular display, but that's what I usually get. Anyhow, so you can see that I guess you can. I mean, so what I'm going to do now is just move the bottom trace down until you can see that these oscillations are quote-unquote phase shifted, right? The peak of the oscillation on the current viewing trace down here is at the trough of the waveform on the Mosfet Common Drains. Okay? Duh. Why would anybody expect it to be different? This is a current and a voltage trace. When the current is high, the voltage is low. When the voltage is high, the current is low. Oh, man. Got any more fish in a barrel that I can shoot? Thanks for watching.